Hi Cougars, in this video I want to go over some problems related to density, and I'm going to start with number 2.67 on page 50 in chapter 2. So first I want to talk about density. Density is a property of matter. It's an intensive property, which means it doesn't matter how much matter you have. It is independent of the amount of matter. It's If it's a certain type of matter, it's always going to have this certain density. For example, water is always going to have a density of 1 gram per milliliter, no matter how much water you have. So, density is equal to mass in grams over volume in milliliters. It needs to always be mass on top, volume on bottom. And if it's not in milliliters, it needs to be in cubic centimeters, which is the same thing as a cc. And you probably heard a cc in on medical TV shows and stuff. Cubic centimeter is what cc stands for. All right, so you can use milliliter, cubic centimeter, cc. They all pretty much mean the same thing, and you just have to be careful. Like if the problem gives you milliliters, your answer needs to be in milliliters. If the problem gives you cubic centimeters, your answer needs to be in cubic centimeters. All right, so let's go ahead and start with problem A. It says a 20 milliliter sample of a salt solution has a mass of 24 grams. So we know that density equals mass over volume, and we are being asked for determine the density. All right, and so my mass given in the problem is 24 grams. So I'm going to write 24 grams here. The volume given in the problem is 20 milliliters. I'm going to write 20 milliliters here. So my units are already correct, grams and milliliters. So I just type that into my calculator and I get 1.2 grams per milliliter, and that's the unit. They don't cancel out. G/ml. You could also write grams over milliliters. These are both right. All right, good job. Letter B. I think there was a problem like this in the homework. A cube of butter weighs 0.250 pounds and has a volume of 130.3 milliliters. Well, what's the first problem? We cannot use a mass in pounds. We have to convert that. So the first step is we're going to convert pounds to grams. I don't necessarily expect you to memorize all of these strange conversion factors as long as you understand how to use them. So let's do 0.250 pounds, and I need to convert that to grams. If I look that up, the conversion factor is 1 pound equals 454 grams. All right, because I have pounds here, I need pounds on the bottom. So that's 1 pound on the bottom, and that's equal to 454 grams. If I type that into my calculator, I'm going to put 0.250 times 454 divided by 1. Of course, we don't have to actually type divided by 1. That'll just give us the same answer. So when you do that, the pounds cancel, and you end up with 113.5 grams. So all I've done so far is convert pounds to grams. Okay, the next thing I need to do is calculate the density. So now I have grams, I have my grams, I have my milliliters, and I'm going to go ahead and solve that problem right here. So too far. So density is mass over volume. Here's my mass. My volume is given to me in the problem, 130.3 milliliters. And if I type that into my calculator, I'm going to get 0.87 grams per milliliter. That is the density of my cube of butter. Okay, let's go to the next density problem. All right, this one's going to be number 2.69 on page 51 in chapter 2. And here we're just calculating the density of a sample of titanium. So we're only solving problem A here. And the reason I chose this problem is because it has the volume in cubic centimeters like I was talking about. So remember again, density is mass over volume. The mass is given to us, 514.1 grams. The the volume is also given to us here, 114 centimeters cubed, which is the same thing as a milliliter, and this is also called a cc for cubic centimeter. So all I have to do now is type that into my calculator, 514.1 divided by 114, and I get a big number, 58,607.4 grams per milliliter, and that's the density of this sample of titanium. Whoops. All right. And last but not least, this is problem 2.73 on page 51, still in chapter 2. So this question wants us to find the mass of a sample instead of the density. So we know that density is mass over volume. In every problem before this, we've been solving for density. Now we need to solve for mass. So let's just plug in what we know. It says, what is the mass in grams of a cube of copper that has a volume of 74.1 cubic centimeters? And it also tells us to use the values in table 2.8. I stuck table 2.8 here for us. And what I want to do is kind of highlight copper. It's down here, 8.92. All right, so our density is given 8.92, and that's in grams per milliliter, equals mass over our volume, 74.1 cubic centimeters. Remember, that's okay. And I should have included my unit here. All right, so now I need to solve for mass. So we're going to isolate the variable. So in order to do that, we're going to multiply both sides by 74.1. Right? This cancels, and I have 74.1 times 8.92. So I'm going to go ahead and type that into the calculator, and I get 660.972 grams. All right, and that concludes this video. I hope that helps. Please let me know.